Now we're going to get into a topic that's probably pretty familiar to most of you in that you had it in Algebra 1. And that is, we're going to be talking about equations for line. And we're going to focus in on the slope and how that slope is related to parallel lines. So two lines having the same slope, that means they're parallel. And we're going to explore that now. So let's suppose we have a couple of lines here, or a couple of points. Okay, here's this point over here, and this is the coordinate, what is it, 2, 1. Okay, so this is the coordinate 2, 1. And then we have this other point over here, and I guess this is, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2. Okay, so we have this coordinate over here, 10, 2. Now, let's suppose that there's a line that passes through these points, and let's suppose that the slope, which I'll denote by an M, is 2, 3. Okay, so that's the slope. Now, let me show you how that's going to work. If we are at this point, 2, 1, and we want to get to the next point, and we know that we have a slope of 2/3, that means that for every 2 units we go to, or every 3 units we go to the right. See, 1, 2, 3, we go up 2 units. So look, I'm going to go 1, 2, 1, 2, 3. And here's the next point on that line. So it tells us you go 3 units to the right, you go up 2. 3 units to the right, go up 2. Every 3 units you go to the right, you go up 2. So we get this line, let me see, passes through, here it is. There it goes. There's the line. Okay, and of course it goes on forever. I just stopped it, but that's the line. Okay? Now let's look at this other one. Let's suppose, of course, it has the same slope. So we're going to go up 2, 1, 2, and then over 3. 1, 2, 3. And we get another point over here, and I will, sketch that. Now, so what we have is we have 2 lines here, and they both have the same slope. And now notice, if I grab this line and drag it over here, notice that it fits right on top of that other one. I mean, it has the same slope. So that's what's going to happen. Whenever 2 lines have the same slope, we say they're parallel. Okay? So in other words, both of these lines, if you're at any point, you move over to the right 3, you're going to move up 2. And sometimes we'll say, well, that's rise over run. You go up 2 for every 3 you go to the right. Okay? So we have a couple of lines here that are parallel. Parallel lines have the same slope. Now, this line here had a point of 2, 1, and then we went over and we get a new point right here. And it's, let's see here, 1, 2, 3, 4, 5, 1, 2, 3. So this is the point 5, 3. Now what I want to do, I want to find the slope. In other words, we already know the slope is 2/3, but let's see how we would compute that. We would say the slope is equal to the difference of the y's, 3 minus 1, okay, over the difference of the x's, 5 minus 2. And you see that's going to be 2/3, just like we said it was. In other words, when we say the slope is 2/3, this is what we mean. So we have a formula. Now, it would be the same way for the blue. We could show that slope is 2 as well. 2/3 as well. So both of these lines have the same slope, and we say, okay, they're parallel. Whenever that happens, they're parallel. So that's an important concept to remember. Now let's look at a different one here. Let's suppose, so I'm going to sketch another line. Okay, so now let's look at this line. Let's suppose we've got a point here, and we've got another point down here. And we want to talk about, okay, what is the slope of the line that contains those 2 points? Let me see if I can draw it straight. Okay, I guess that's good enough. we want to talk about the slope of that line. Okay, well, we've got a point here, which is 2, 3. See, we go over 2 and up 3. And then we've got 1, 2, 3, 4, 5, 6, 1. So this is the point 6, 1. Okay, now we want to talk about that slope. So here we go. We're going to take the difference of the y's over the difference of the x's. Now, it's very important that if you start up top with the y's, this y coming first up top, then this x needs to come first on the bottom. It doesn't really matter which way you do it as long as you're consistent. In other words, I could have said this. I could have said, well, I'm going to do 1 minus 3 over 6 minus 2. I could have done that. You just have to be consistent. Now, if you look at this one, we're going to have 2 over negative 3. Okay, negative 2/3. This over here is negative 2 over positive 3. Now, in both cases here, you see the slope is negative 2/3. Now, when you have a slope of negative 2/3, you're always moving to the right. Okay, so let's suppose I want to find another point on this line. I'm always going to move to the right, no matter what the sign of the slope is. If it's negative or positive, the sign tells me whether or not to go up or down. So here, I'm going to go down 2. So to get to my next point, I go down 2, and then to the right 3. 1, 2, 3. And that should be my next point. I mean, I don't have it drawn exactly in the ideal way, but this is how you deal with slope. So we have a slope. If we have 2 points, let's just see how this goes. We have 2 points. We have x1 and we have y1. That's a point. And we have x2, y2. That's another point. The slope is always going to be the difference of the y's over the difference of the x's. Always. Now, that's a very important formula. There's a lot of implication in this. Measuring the steepness of this line is a very important concept. Okay? So we have, anytime we have 2 points, we can find the slope of a line that passes through those 2 points. If the line is decreasing, in other words, from left to right, if it's going down, that slope is going to be negative. If it's going up, that slope is going to be positive. Okay. Now, let's suppose we want to, let's just look at this a minute. Let's suppose that we've got 2 points. Let's suppose we've got, let's just write a line here. Okay, and I'm not even going to pay any attention to what the slope is. Let's just suppose I've got a point here, and this is the point, I'll say x naught, y naught. And then we've got this line. And don't pay any attention to the grid on this one. I've just got this point xy. Okay. So I've got these 2 points. This line passes through x naught, y naught, and xy is just some other point on the line. Now I want to find the slope of these two. Okay, so the slope is going to be y minus y naught over x minus x naught. That's the way I say x sub 0, x naught. Okay, now that's the slope of that line. Now, look at this relationship here. We have y minus y naught equals, well, over x minus x naught equals the slope. Now, look what I can do here. If I want to, I can multiply both sides by x minus x naught. And notice the x minus x naughts cancel on that side. And look what I get. I get y minus y naught equals m times x minus x naught. This is the point slope form of a line. Point slope form of a line. So let's see an example here. Let's see if we want to write an equation for a line that passes through through, let me write better. Five, 7, and is parallel, and has a slope. Let's just do this. And has a slope of m equals 2/7, let's say, or two. Let's do 2/9. Okay. Well, look, this point right here is 5, 7, x naught, y naught. That's 5, 7. And the slope is 2/9. So look, let's just plug into this formula. Y minus y naught. So y minus 7 equals 2/9 x minus 5. See, here's x naught, here's y naught. And there's our equation for the line right there. That's our equation for the line. Now, let's look at this. Let's suppose that we're passing through the y-intercept. Let's suppose we're passing through the y-intercept of 0, 8, okay? And our slope is 2/9. So in other words, I'm modifying the problem a little bit. I'm saying, okay, instead of my point being 5, 7, let's make the point the y-intercept. The y-intercept is what happens when the x is 0. That's where it passes through the y-axis. So now look what we have. Y minus 8 equals 2/9 x minus 0. Oh, look at that. Y minus 8 equals 2/9 x. Or y equals 2/9 x plus 8. Now this is this form. Y equals mx plus b. Mx plus b. This is called the slope-intercept form. The slope-intercept form. Now, if you want something in this form, here you can clearly see the slope and where it crosses the y-axis. This, you can't see the y-intercept with this one over here. However, if I were to solve this equation for y, I would have it in this form. So let's take a look at that. Let me skip down here a little bit. Get some more room. Let's suppose that we have these 2 points. Let's suppose we have 1, 7, and 4, 2. And I want to write the equation for a line that passes through those 2 points. Okay? Well, here I go. I need the slope. So I got 7 minus 2 over 1 minus 4. Okay? Difference of the y's over the difference of the x's. And that's going to give me a negative 5/3. Okay? So here is my... Now, I've got my slope. Now, I can pick either one of these points for my x naught, y naught. I'll pick this one. I've got y minus 7 equals negative 5/3 x minus 1. Ah, there's my equation for the line right there. No more to it than that. Now, let's suppose, I want the slope-intercept form. This is the point-slope form. Well, I need to solve for y. So I get y minus 7 equals negative 5/3 x plus 5/3. See, I just distribute it. Now, if I add 7, there. Now, I need to add this fraction, of course, but you can see I've about got it. So let me go ahead and finish it up. Y equals negative 5/3 x plus 5/3, let me see, My common denominator is 3, so this would be 21 thirds. So y equals negative 5 thirds x plus 26 thirds. And now you see the slope and you see the y-intercept. Okay? Now, let's suppose I want to write an equation for a line parallel to this thing, okay, that passes through let's say negative 4 at 5. Okay, well, I've got my slope and I've got my point, so it's going to go y minus 5 equals negative 5 thirds, because it's parallel, so it has the same slope, x minus a negative 4. So let's see what we've got here. We've got y minus 5 equals negative 5 thirds x plus 4. And there you have it. So you can see how we can use parallel lines to, if we know that our line is parallel to another line, then we have the slope. And that's the main concept in this section, that parallel lines have the same slope. Now, if you look at your assignment here, you have finding the slope just using the formula, determine whether two lines shown in the graph are parallel. Okay, well, they're parallel if they have the same slope. And then on this, you're just going to be using y equals mx plus b. So write an equation of the line. If you have the y-intercept, well, that's 2. Okay, so the b would be 2, and the slope would be 3. So y equals 3x plus 2. Okay. Now over here, you can see the slope on all of these. Okay, slope of negative 6, the slope of 1, the slope of negative 4 thirds. Okay, all righty. Okay, well, if you need any help with these, just let me know.